very quick recap then. So this is the VCP-NV Objective 2 by Wynne, and yeah, this has been recorded, so it should be hopefully on YouTube and on iTunes relatively soon after this, and then also we'll try to put a blog posting of it also if you want to re-watch it or watch it another time. And yeah, I think that's about it. Obviously, if anybody listening to this, watching this live, or watching it downloaded, if you want to do one of the objectives, get in contact with anyone from the vBrownbag, and we'll try and get you logged in. We're always looking for presenters. And yeah, I think that's about all from me, to be honest. Just thank you to Ross for coming and presenting. It's always helpful if people want to present, because that's what we're based on, or else you'd have to listen to me, and I'm certainly not as clever as a lot of our presenters. So let me make you a presenter, Ross, and then the hour will be yours.
Okie dokie. Can everyone see my screen okay?
Yep, VCP-NV
Yep.
Objective 2. Oh, and everybody, I've got you all on mute. If you want to be unmuted, raise your hand. I just mute everybody because sometimes people don't realize their microphones are on and they're shouting at their cat. So
No.
I'll just
Okay.
mute everybody.
Okay, welcome everyone. This is obviously Objective 2 of the Network Virtualization VCP. I entitled it a crash course of what the network guy knows. A friend of mine actually pointed out today that I could also entitle it a crash course in what the vSphere guy knows, because obviously our friends over with Cisco certifications are quite able to go now into this VCP directly. As I said, my name is Wynne. I had a splurge of interest in certification over the last 13 or 14 months, and I became a bit of a certification junkie, hence the ridiculous number of letters there. In essence, I've just got a very deep interest in data center design, cloud design, administration, etc., and networking is what was initially this year one of my weakest points. So the VCP-NV is a fantastic way of actually getting to know about the network side of things, getting to know about that north-south, east-west type networking scenario, and just basically brushing up so that if anyone's doing VCX Defense or VCAPs or anything like that, they feel a little bit more positive in talking about networking. So actually one of the things there, this is so new certification, that logo at the bottom, you cannot actually download it off the VMware site, and even the certs themselves aren't available in my VMware. They actually haven't prepared it in the background. So this is a brand new cert, 3 or 4 weeks old, so there's not a lot of information out there. So we'll crack in onto it. So I'm going to start off with the more networky side of things. Now, one of the objectives is to know about the Layer 2 fabric, and everyone's home has a Layer 2 fabric. It's basically all your boxes onto a Wi-Fi point, and then you've got a point then that goes off the internet. All boxes on that network talk to each other in a Layer 2. In the networking world, the Cisco world, people call that the data link layer. It's the one layer above having just physical network connections between boxes. It's above that metal in the cables. The actual communication between all the devices on that network are actually done via MAC address. Now, you may go and chime, oh, but I IP my boxes. True, but that IP address is primarily used for routing and to go between network devices. If I go and send out a packet to a particular network, I'm actually looking at my ARP tables on my VM or on the network switch. Those ARP tables have a one-to-one correspondence, usually, of IP address to MAC address. And that is the way you communicate within your network packet. You don't see it, but it happens. So as an example, I'm just going to fly through this. If a VM, or 2 VMs on the same network, on the same Layer 2, sharing the same network mask as well, go and try and communicate with each other, they do it via MAC. If the first VM doesn't know the MAC address, it sends out a packet out to the switch saying, what's this IP's MAC address? The switch then goes and says it either knows it or it doesn't. If it doesn't know it, it sends out a broadcast to all ports going, do any of you know this particular IP address? That MAC address, if the VM or box or whatever is online, it will respond back to the switch saying, hello, this is me, and the ARP packet is then, or the MAC address is stored in the ARP table on the switch, then sent back to the original device, and then from that point on, communication happens. It's a fairly straightforward thing to do, and everyone here knows what Layer 2 is, because that's your vMotion VLAN, your VXLAN transits, your fault tolerance networks, ISP networks, private heartbeat networks. There are occasions where you might do Layer 3 vMotion. As far as I'm aware, it's on support in 5.5, but VMware can do a hack to make it actually work. And certainly in future versions, that's certainly going to be a big thing. But for now, we know most of these things as Layer 2. They're encapsulated networks. You can't route them, you can't ping them from your desktop. They're just absolutely private, and they go between the boxes. I'm bringing this up as a topic for NSX because if the network guys will come to you and go, oh, but these type of things will cause broadcast storms. If you're going to have so many VMs on a certain network and all that, you have to care about broadcast storms. In the NSX world, all that bit where you're looking up the ARP table on the switch, that's done with the NSX controller. We'll go into that later, but essentially that layer of ARPing and looking for MAC addresses, that's resolved using the NSX controller. I believe there were some issues with version 6 and 6.1. There's been some additional changes so that items other than just doing a simple ARP request have been resolved. That's something from an NSX point of view you might want to just note. Certainly very interesting for an exam. The objectives talk about multi-tier networking. Now, I've ripped this diagram directly off the Cisco website, and I've also ripped other diagrams off the VMware website, so I apologize to whoever created this, but here we go. Usually what you have is a traditional three-tier network. So you're talking for a medium to large data center. You'll have your central core. That central core will be, you wouldn't have traditionally network servers or PCs or anything like that plugged in onto it. You're talking about pure network routing. You may have other routers going off into the internet or VPNs or anything like that hanging off that core, but essentially that is your core networking infrastructure. If you're in a Nexus world, you'd be talking the Nexus 7000, 9000 layer. They are the big VMops that sit up in a single rack somewhere in the middle of your data center and then have all the cables going from it. The distribution layer, it's also known as a end of rack device. So instead of the core going and sending out cables to every single rack, you do it to the end of rack distribution switches, and they in themselves do layer 3 routing. So that's the routing between different networks. In the Nexus world, that's the 5000 series, and then on the access layer, that will be your top of rack switches. Sometimes you only have a patch panel, and it will go back into distribution layer. There's so many different ways to skin a cat on this one, but in the tail end, the access layer could end up just doing basic layer 2 switching. So from host-to-host communication on a layer 2 network, so such as VXLAN or on a vMotion, whatever, that could all be done at the access layer if needs be. Traditionally, the access layer has the simplest port config you can hope for. That is the plan from a networking guy's point of view. The main benefit of this is you're reducing the amount of cabling going around your data center. What you don't want is cables traipsing from your core directly to your server, which is two tiers away, several racks away, and it just is a cabling nightmare. So this is why you have your end of rack switches and your top of rack switches. So what you can have in a more smaller data center will be a core and an access layer. This will be known as collapsed core. This is where you wouldn't need a distribution layer because you don't have that many end of rack scenarios. The core would still do its normal function of going out and doing your internet, WAN, VPN, etc., but it goes directly to the access switches. Now, these access switches, I've seen them being layer 3, so the actual routing is done at that level. Could also be layer 2 and go straight back to the core for all that type of network switching. Again, different ways of doing things. The implementation I'm currently working on, this type of model, if it was a greenfield site, would have been perfect, because we're looking at doing maybe up to 6 racks, all ESX hosts, a couple of Nexus cores either end, and top of rack switches. This is a very simple scenario. It keeps down your number of racks down to maybe 3 or 4 racks. It makes it lovely and simple. The network guys like to keep it up to maybe up to 6 racks, and they consider that a pod, and at that point, then you might want to bring the distribution layer. Then again, your setup might be different. The traditional photo everyone sees of the cabling nightmare network can be. If you have a core and you decide to cable directly from that core to servers, that is what you will see. I've worked in a data center that looked like that, and it was an absolute fun time trying to trace the cables. Luckily, we had different colors, but I think you get the picture. It is not fun. So one of the things that you're going to come across a lot, whether it's VCX defense, whether it's working through the network guy talking about which way the traffic flows, you may come across this east-west, north-south type of discussion. And essentially, east-west is your simple within your vSphere layer. Basically, you're talking from a switching perspective, very close to each other. North-south is basically when you're going out and using external devices, or going back out into your corporate network, connecting onto your laptop, going out for the firewall to the internet, etc., etc., etc. It's certainly within a host, it will be just layer 2 traffic. If you've got a very simple ESX host configuration where you've got all your VMs on a single network, great. If the VM is other VM you're communicating with is on the same host, you're at wire speed. It's basically, it's pretty much faster than 10 gigabit. That's what is essentially being discussed. You could also do some layer 3 as well if it's just going out onto an access layer and then come back in. North-south traffic is going out to your database servers or your load balancers, etc., etc. The bit where you really get concerned about is your upload between your ESX pod of hosts and out onto the wider network. Sometimes there's a bottleneck, and certainly if you're maybe putting a vShield Edge or some other router in the middle there that summates all that traffic and then sends it outbound, that can be a very hot networking device, and you can sometimes get performance hits. So what you have in the NSX world is you get to actually integrate certainly some device like an F5 appliance, which I prefer, can all be considered then into an east-west scenario if you build it right. Distributed routers and module switches are contained within the ESX host. So at that point, you're only relying on your VXLAN transit for your transport, for your data packet to go from one ESX host to the other ESX host and from VM to VM. All the objective switch layer, only a single layer 2 network is required across all hosts. This is for your VM communication. This is what you would traditionally think of as your VXLAN VLAN. If you're very aware of what was in BCNS, this is basically that VLAN you type in when you're setting it up. All communication between the hosts is on this. What you have connected onto these are what's termed VTEPs, and we'll discuss that in a bit. But these are the IPs, the hosts that you connect out onto and actually share via multicast or unicast the actual VXLAN traffic. For north-south traffic, NSX has introduced this little blue object just above the east-west line, which will be your logical router. I've seen it as perimeter router, and there's a couple of names that float around for it. It is basically what you would consider your bottleneck. This is your virtual routing device, which can do firewalling, load balancing, and other various features. However, to get through that bandwidth requirement, certainly in the place I'm currently working, we have a requirement for 12 gigabit peak load to go through between the ESX host and out onto public internet and all the rest of it. So we need that routing device to actually be highly performant. A single edge, frankly, wasn't going to be capable of doing that. We've tried other routing devices, and NSX seems to be the only solution, simply because we can actually go and look at doing what's termed ECMP load balancing, equal cost multipathing, if I remember rightly. And you can have up to 8 of these devices within an NSX manager. That's an important thing to note for the exam. That is set up in a active setup. They're all spreading the traffic across all 8 devices, and you use OSPF to actually set your cost weighting for a network packet to go from the top to the bottom of your stack. OSPF is a part of dynamic routing protocol that basically allows a routing device to actually say, hello, I've actually got this networking subnet sitting behind here, and you advertise out to the outside world. It's as I say, it's dynamic. You can do a lot of damage with it if you set your weightings too high or too low. So if usually a network guy comes along and he knows the actual weightings involved, be very careful with your OSPF configuration, because it will be considered pretty much a tier 1 type change in your networking infrastructure. So do it wisely and do it right. When I mentioned F5 there, F5 and Arista and a few other vendors have started introducing basically the NSX components for this to actually be integrated into an east-west scenario. So instead of boxes or traffic having to go out through logical routers where there's a bottleneck, you can essentially plug in these F5s into these VXLAN aware VLANs and have them actually talk natively to the VMs without there having to be this contended traffic. Reduce down the bandwidth going through your logical router, and that can be dedicated for your actual serving your customers out on the internet if you're running a big corporate website. The VTEP itself, down the bottom, this is what you would have seen in your VCNS manager. This is when you set up your VXLAN cluster. I've done this example here on my own home network. A couple of IPs set up statically on a dynamically created VM kernel port. You're only allowed one VTEP in 5.5 and earlier, and that basically is tied to the MAC address, essentially, of the connection coming out. So in a failover scenario, you've only got essentially one MAC address that's being advertised to the world for all traffic to go through. Ether channel will be the same because it's teaming, and it's essentially one MAC address being published. Same with LACP. They're set either by DHCP or statically. As I said there, I've set it there manually. When you set up a VXLAN cluster, it goes and creates the VMK port across all nodes automatically. Don't try and set up it in advance. It will be used. It will be created dynamically. It will come up with probably a 169 type IP address. Go in and set the IP afterwards. There's no issue doing that. It's a fully support configuration. DHCP is obviously an option if you're allowed to do DHCP in that type of network environment. I haven't really worked in server environments where DHCP on a server has ever been tolerated. It's always been static, so you can document it and you know it for life. And in 5.5, VXLAN traffic between hosts is by multicast only. This introduced a bit of an issue if you wanted to go across site. So if I was in data center 1, I want to send over to data center 2. First, essentially, I need to stretch VLAN. Secondly, I need to have multicast being repeated across the network. It's a horrible configuration. Some network guys don't do it. It's a big hindrance, and certainly I haven't ever seen it actually implemented. I'm sure other people have, happily, but it does cause a bit of a headache. So NSX 6, and the big thing was it allowed multiple VTEPs. You can have either source MAC or port ID being the load balancing methods allowed. The other failover Ether channel LACP are there supported. I meant to say also in VCNS 5.5, I believe LACP2 is also supported as one of the teaming policies. From what I can see in NSX 6, although I haven't actually gone through into the menus, is that the actual VTEP IPs can be set by an IP pool. So that function that I've rarely ever used could actually be finally used for good if you want to. It's an alternative for DHCP. And one of the big things with NSX was the unicast transport of VXLAN frames between hosts. That finally allowed us to actually go and send those packets over to hosts in a second data center and actually have that Layer 2 network spread across 2 sites without the network guys having to worry about anything. You can control it as the vSphere and NSX admin. So there's the unicast bit. Multiple VTEPs is when load balancing, when LACP is not supported or desired. We didn't use LACP because we want to use the ESXi dump collector to be able to capture all the kernel dumps. There's also the fact that we're actually using 10 gig pipes. We don't have anything that is going to be driving over 10 gig coming out from a single host. So LACP wasn't necessarily required in our implementation. But some guys need LACP. You know, it's not a, some people get religious about this, but it's not a requirement. Going on to the different routers, you have your traditional app edge router. It's the classic VCNS edge. It can only do static routing, and it can only do HA in an active passive setup. While I've skipped down 15 seconds there, I have been able to see that you can actually set up the dead time, which is the time that basically the active node can ping the passive node. You can set that down to as low as 6 seconds, and it will ping around every second. So after 6 seconds, if it hasn't heard a heartbeat in that period, the passive node takes over. Now, that can actually add on several more seconds for various functions like load balancers, firewalls, etc., those sort of services to start up. So traditionally, you basically say 15 seconds. I've seen that go to 30 seconds. It was one of the reasons why we didn't actually go for VCNS edges primarily, because we couldn't tolerate 15 seconds of an outage. An app edge router is also an appliance, so therefore is another virtual machine, is limited up to 10 network interfaces, just like any other VM is. And they're in a vCloud Director environment, they're dynamically deployed by tenants, whether that's in a NATed vApp deployment or via an org-rooted network. Distributed router is the absolute business for NSX. It is fantastic. It's a VIB that's installed in the hypervisor, and basically all routing is done at a hypervisor level. What this means is that all that routing going between different wires or logical switches, is basically whichever terminology you want to use, it's done on the ESX host level. It is done at wire speed. That is basically if it's on the same host and you're routing between the 2 networks, it is done as fast as it goes between goes through the CPU. The HA first is the ESX host HA. If you lose a host, you've essentially lost all routing of VM traffic on that box. It's not really a big loss because you've also lost all the VMs at that point as well. So it's not a big deal with that failover. And that distributed router can have up to 1,000 interfaces. That 1,000 interfaces means pretty much 1,000 logical switches plugging in onto that distributed router. That's a lot. That's a hell of a lot. And you essentially just have to manage one distributed router across all these hosts. What I've been told is that a full pelt, when you're going and doing multi-gigabit firewalling, going through an NSX distributed router and distributed firewall, you are probably using on the high-end servers about 3% of CPU. Remember that the app edge routers, they would actually be contending for CPU along with all the other guest VMs. And then you've got your big logical provider router, and that's the one where you can have up to 8 of them. It fulfills the same criteria as what VCNS Edge can do. It can do load balancing, it can do firewall, it can do routing, and various other activities. But it also supports dynamic routing. Remember these particular routing protocols. These are important. OSPF is traditionally the one that's quite common. BGP also. ISIF, frankly, I didn't even remember seeing that in the CCNA, and other people I've actually spoken to, they've never seen the implementation of that. Again, that logical router is active all the way across, up to 8 in the ECMP configuration, I did speak to an NSX engineer, and he said that it was possible to actually deploy up to 16. Now, I didn't see that in any documentation, but those extra 8 will be in a passive mode. But we need to check the documentation for that, but up to 8 is basically the magic number. It is the choke point for north-south traffic, and certainly if you've got 8 of these devices and they're all running 10 gig virtual NICs, it's not much of a choke point really. You can have up to 80 gigabytes going through. HA is still 15 seconds. It's still essentially a VCNS edge, but on steroids. But because of the dynamic routing and the OSPF convergence timing, it can be reduced down to 3 or 4 seconds. It's a 1 second heartbeat and a 3 second dead time. So the packets will be lost across 8 CCNP routers. You lose 1/8 of your network traffic for about 3 or 4 seconds. It could be enough to tear down a TCP session, but more likely it will be a case of, oh, I didn't receive that packet, try again, and you can recover from that. Into the edge and distributed firewalling. The traditional edge firewalling is that if you have your back-end databases, you've got your business logic / application tier, and then you've got your web servers, you'd probably put them on different network or different networks with their own IP range. The firewall will be at the router point, so it will be termed zonal. The rules will be based on IP, port, protocol, etc., etc. And it would, if you'd had 1,000 rules in that edge, likely but possible, you would have to go through all the rules until one of them matched, or you hit the default rule. That in itself can actually add some latency. If you needed 2 VMs on the same network, you have to resort back to your old-fashioned Windows firewall or IP tables. And also you're having to do that inside the VM manually. It's not in some type of automated fashion. Maybe you'll do it by a Puppet or Chef or something like that, but it's not really a nice scenario. And also it increased CPU cycles as well on the individual VMs. The edge VM, as I mentioned, would have the same CPU contention issues. If you needed a high-performance edge, you would have to deploy, let's say, 4 vCPU. You are then going to be looking at CPU-ready hell in a very busy and contended cluster, and that is where no one wants to be. So the distributed firewalling, the big thing the sales guys go on about is microsegmentation. I'll deal with that in a few moments. It is what is basically the selling point of distributed firewalling. The firewall rules are set down on the VNIC level. So they're not inside the guest, they're around the hypervisor layer, but it's the bit that points in or connects between the DB switch and the VM. VMs on the same layer 2 network can now be firewalled between each other. The rules are actually set that if you've got a big master rule set, let's say 100,000 rules that have been built up over time across your entire environment, only the rules that apply to those particular VMs will actually be sent down and actually apply to those VNICs. So that bit where you're having to go through all the list of firewall rules is gone. Rules can be based on the name of a VM. This is a big thing. In the environment I'm in, if I'm sending out a production box that's called ABC, or an application ABC, I'd name it that, and then as soon as it was booted up in vSphere, NSX would say, oh, it's production ABC. And then all the firewall policy will be applied for that particular application. It really enables us to actually stop thinking about zones, firewalls, IPs, all this type of stuff, and think about the application talking to another application, the simple things in life. I want to know that my website or my web layer talks to port, let's say, 443 of my application layer. That's all I need to know. I don't need to be putting in particular IP addresses or anything like that. I just need to know what I should be able to speak to. The VM, when it moves around via vMotion, carries firewall policy. The NSX controller is responsible for all firewall policies being pushed down. NSX Manager and its API is there for you to actually create your rules, but controller is the place where it actually has the master set and distributes it all over the different ESX hosts when needed. And again, it's run at the kernel level. It's not subject to gang scheduling. Therefore, you don't get that contention. As I said, we hear, the number of hours here was 3% of your host is used up at this firewalling and routing process. That's a very big thing. especially in latency sensitive applications. The microsegmentation, again, we're talking about this bit where we have our web network, we have our app network, our database networks, and then we're doing our perimeter firewalls on each one of those, and then you're talking to them zonally. It's quite traditional. Most people would have it. Certainly if there's any financial stuff in the way, it's almost like a must-have. The new world can sit on the same network. Massively simplifies, and certainly for my world, a vCloud Director type deployment, where I might have a front-end type virtual data center, a business logic virtual data center, and a database virtual data center. Sorry, tripping over my own tongue there. I can basically have a production virtual data center. It will be on the same network. Microsegmentation means that the VM that is IP address .2 to speak to the IP address .3, and there will be a firewall between them if needs be. It simplifies my network design. It simplifies my organization and virtual data center design, and it means I don't have to be splitting resources, CPU and whatever, and trying to balance them between multiple layers dynamically at any one time. They simply have all the resources they need within their virtual data center, and away you go. In our example here, we are talking about a multi-tenant environment. We're talking about our classic cloud environment. We're talking about having, in this case, n different tenants. You can still combine the old-fashioned VCNS edge and have that as your perimeter for your endpoint, or sorry, for your tenant, for going outbound into the internet, and have all your VMs all behind the scenes. But then you have your NSX side, where you have your ECMP'd provider routers, and you have all that type of control being sent down to the individual VMs. It just shows that you can actually integrate both. This could easily be what it looks like in vCloud Air going forward. Certainly, their current implementation, I believe they're looking at NSX maybe next year. But this will be a very classic implementation of cloud and multi-tenancy. A lot of the stuff that we would have to do otherwise, if we weren't doing that multi-tenanted on-demand environment, is pre-create everything. And when you do that, you're creating your logical switches. You'd import them into a vCloud Director environment as an external network, and you would use it as such, just like a regular port group. You could have your load balancers being just a regular VCNS edge on a stick, as it were. When you're in ECMP mode, be warned. It stops the provider tenant router, which is called here. Again, it's got so many names. I've also heard there's a logical router. It actually disables firewalling and load balancing functionality on that actual router, and it simply becomes a standard network router. So be warned on that one. There are some benefits and there's some losses when that happens. And when that happens, then you look at your distributed firewall, your distributed router, as being the thing that gives you the type of performance on the back end. One of the things that you'll see in networking design, you'll see your things like jumbo frames for your storage, but one of the things you need to care about with VXLAN, if you haven't worked with it, is your maximum transmission unit, your MTU. Now this is set both on the network switch side, where your ESX host connects onto, also your DV switch. And with VXLAN, it takes a regular network packet and then adds on a little header. And that header is basically the bit which is VXLAN and basically communicates between all the hosts together. The standard MTU size is 1500. Again, as I say, when you have VXLAN, the recommended value is you set 1600 as your MTU value. When the NSX manager is doing a ping test, when you're setting up these logical switches and verifying your infrastructure is being correctly set up, it will send out an MTU packet of 1550. And if your MTU isn't right, it won't work. There is situations where I've seen it where packets just get fragmented. But I've recently done implementation, forgot to do the MTU size on a particular port. It just wasn't working. I was racking my head and went, I forgot about the 1600. No, I changed it, bang, it was pinging, and everything was working great. Your NSX model, your actual setup on it, you're looking at a management layer. Now, again, I apologize if you guys don't use PCI Director or have that type of setup at all. But in my world, what we would have is a management layer. And we'd probably have two management layers, one for our first data center, one for our second data center, all primarily around having the capability of doing SRM of your own vCenter between two locations. So where I will be putting in my management layer will be NSX Manager. It is a direct replacement for VCNS Manager. In fact, there's even an upgrade file that you install in VCNS Manager, and magically it changes all the logo and all the marketing gumps, and suddenly it becomes NSX6. Within that management layer, you could also have all your VCOPs, VCD, VCO, Virtual Center, etc., etc., etc. And that's where I'm going to be putting it when I do my own installation. My resource layer, which is where all my consumer deployments happen, it would contain at least two clusters. One is going to be the edge cluster. That is where I go and I put my NSX controllers and the edges. Now, I'll tell you how many controllers and edges and all that later on, but that is a standard scenario for how you do this. It is supported, or at least the engineer who was suggesting it to me was, that you could have your edge and your compute clusters actually doing all the same stuff. So you don't have to have this edge cluster, but in an environment where you are relying on an edge, actually, when I say edge, I'm talking about a perimeter router, when it's very, very busy, you want to give it all the CPU cycles it needs. You do not want to add latency. Adding latency there will probably add on latency onto your VMs. Your VMs themselves will start increasing their CPU because they're going into wait states, and it just starts building up, and it's not a pretty sight. So the edge cluster should be basically almost like a one-to-one contention-free environment. And compute clusters, whatever you want. Ideally, put them beneath the same distributed switch. Don't have to, but in my world, I would be doing it like this, and I'd have all the ESX hosts connecting out onto this DVS. The reason why you might have two different DVSs is that you would have a very simple setup on your compute DVS, which may be just your network traffic, but on your edge DVS, then you've got all your transport layers. You've got all your transits out into your native production or your native database layer and all the rest. You could have much more complicated network scenario there. I don't know if you can combine them. I imagine you can. I don't see any particular reason. There's nothing in documentation to say you can't actually have a single DVS across your edge and compute, but it just means that you have a slightly more complex DV switch. So moving on to just the controller and edge requirements. NSX Manager, it is a one-for-one installation. I'm just checking my time here. Good. It is a one-for-one for vCenter. So one NSX Manager, one vCenter. Same with VCNS Manager. It is deployed, again, in the management layer. As you can see from the specifications on the right, it's a beefy box. I believe it's pretty much public knowledge now about vSphere 6 and fault tolerance and all that stuff. If you notice the number of vCPU count, that is looking pretty nice to have as a fault-tolerant VM. Pretty much built around this. I know people who've actually gone and used fault tolerance for their VCNS manager. I wasn't fortunate doing that because we had to add on extra CPU because it did get busy at peaks. But you could actually look at possibly setting that up in that type of scenario. The NSX controller, it's recommended to deploy it in odd numbers. It's whatever the logic is behind it, I'm not too sure, but from documentation point of view, from an exam point of view, odd numbered NSX controllers is the correct answer. And they are deployed in the edge cluster. The controller itself, again, they're beefy VMs. They're the ones that do all your ARP caching, that bit that was on slide number 2. and hold all, or at least distribute all the firewall rule sets and any other type of rule sets that will be required. They are your controllers. All the lights stay on if you lost all your controllers. You don't need a controller to always be on for everything to work. If there is a routed path between two VMs, between two different networks, and the firewall rules have already been set open, if the attacker has already done that journey and all the controllers suddenly went down, data still flows. You do not lose anything. Now, if a VM suddenly starts vMotioning over onto another host, I can't say for sure what the actual situation would be, but you would certainly be safe with your traffic at that point in time. Your NSX edges, again, up to 8 edges in ECMP mode. That's for your entire vCenter. So use them well, use them wisely. That type of setup is possibly going to be forcing myself to actually have to set up a second vCenter just because I might need 4 edges in one data center, 4 edges in another. And I don't know how much traffic is. If I'm using more than 3 edges, I don't want to go into something less than N+1. So you need to be careful about that 8-edge limit. Again, these are beefy boxes. If you have a look at the stats on the right, you're talking up to 6 vCPU. That's a lot of cores that you're going to need in that edge cluster just to dedicate to these type of edges if you're in that type of high bandwidth, high transactional networking space. They're deployed in the edge cluster, needless to say, and as I said in one of the previous slides, edge routers, or at least what I should say, they're actually the perimeter routers. The functionality simply on those perimeter routers becomes routing only when you switch on ECMP and you have that active type setup going on. Bear in mind these type of numbers. Bear in mind this page. You might get a question or two of this type of information when you're actually doing a VCP-NV exam. It has been a week or two, so I can't actually remember quite well. And just some general notes that should just be followed. While you can easily do 1 gig networking with all this, there is no demand for 10 gig. The reason why you might want to go you do in a 1 gig fabric is if you want your software-defined networking, if you want your firewall policies to be simple. If you want that distributed firewall, basically your topology looking very nice and straight and simple and all the rest of it. But there's also the big element of performance that you have to concern yourself over. And why would you be looking at ECMP and all those type of functions, which, let's face it, NSX is not a cheap product. You're going to be looking at throwing in 10 gig networking throughout your host if you can. Again, this could work fine on 1 gig networking, but it makes sense to have the infrastructure around 10 gig. If you see any of the VMware stats, I think there was stuff like a host can do like 18 gigabit of routing with a distributed router, and that's per host, and it's linearly scaled. So 2 hosts, 36 gigabit, etc., etc. A lot of tests were done around the 10 gig X540 Intel NICs. There's a lot of offloading that can be done on those NICs. A lot of stuff that can be just ditched from the ESX host itself, hence why you probably got down to that only 3% utilization on the actual hypervisor itself. That is what they've actually built it around. I believe the X520 is also perfectly fine. I'm sure there's an entire list a mile long on the HCL that would actually guide you towards the right NICs to use. But if you want top-end performance, or at least you want performance that they've seen and tested against, obviously in fairly interesting situations, they would be the type of NICs you'd be looking at. When you deploy it onto an ESX host, and you add these into these, you prepare these hosts in NSX Manager, you're looking at installing 3 new VIPs. One is the VXLAN, which we had back in our 5.5 days. And one thing that I kind of will mention on the actual webinar now, when I was doing my VXLAN upgrade between 5.1 and 5.5, I found that VMs that were still on hosts that were running on 5.1 VXLAN, when they tried to connect to a 5.5 enabled VXLAN host, the network traffic wasn't happening. Now, I've been told, oh, that shouldn't happen or anything like that. It could be a bug. bear that in mind if you're going up to version 6. I certainly will be when I'm doing the upgrade next week up to 6. This is something that you just might want to bear in mind. Distributed firewall, logical routing, that should be distributed routing, I'll correct the slide. They are VIPs that are required. They are their own individual functionalities. Again, you can use these things if you need them or not. You don't have to use distributed firewall. You could use that perimeter firewall. You can use the old-fashioned VCNS edges and their firewall if you wanted. You don't have to use distributed firewall. It just makes sense in a high bandwidth and high throughput point of view. And I don't just mean megabytes or gigabits per second or anything like that. I'm also talking about packets per second as well. They're the real thing you need to concentrate on when you're doing a network design. Really around the packet size, number of packets, and also packet size. And then the edges that are deployed in vCloud Director, they are not anything special. They are essentially a 5.5 VCNS edge. They are no special NSX type edge for your type of apps or for your natting of the app networks, etc., etc. They are, what you have today is what you're going to have tomorrow. At least that's what I've been told and what I've actually worked through already. I'm going to throw in, I believe I've only got probably about maybe 10 or so minutes left, maybe 15 minutes left. So I'm just going to go through some exam hints, just give you guys some knowledge. I'll post them up on my own website, but I thought you guys should actually know what you should know from a networking point of view. Know your difference between standard switch and a DDS. Believe it or not, standard switch is something that is still around, especially, in fact, of course, around because a lot of people won't be on Enterprise Plus and who get their distributed switches. But know the difference between them. Know about your teaming requirements for standard switch and distributed switch. What a VTEP is. Again, this is the IP address that goes between hosts for VXLAN traffic. Be aware of what it is. It is fundamental to what VXLAN does and what NSX does, especially around that multicast, unicast, and hybrid setup. MTU, simply put, it's straightforward. You need 1600 MTU for VXLAN to work. So know about your ping sizes, know about how you actually set it, know where to set it, and then you'll be safe. Again, these are all low-hanging fruit questions. This is stuff I would be expected to be asked. This isn't giving away any secrets or anything like that. These are fundamentals. If you want to know anything about networking, anything like that, you need to probably know this stuff anyway. Know what multicast is and its limitations. Again, this is the limitation being that it's a bit harder to route. You have to set up what's known as PIN, PIN, on the actual router or on the switches and routers for actual multicast to actually go between particular VLANs, between subnets, etc. It's a headache, and the network guy sometimes doesn't like having to do it. Sometimes switches don't actually support multicast routing. Now, at best, they will be the cheaper end of switches, but still, it's more of a headache to actually have to set up. But what multicast is you've got unicast, multicast, and broadcast. Unicast is IP to IP. Everything we know, everything we love, everything we do on a daily basis. Multicast is when I send out a packet from my VM out to 3 other VMs on that same network. They're part of a multicast grid. This is what VXLAN is. And then what you have is broadcast, and broadcast is basically a shout out to everything on that network. This is where a lot of your broadcast storms will come out. This is where your ARPing requests come out. If you've got a network which is known as, let's say, a /24, so you've got 253 VMs you could possibly stick on there. That is a big broadcast. That is a lot of network chitter-chatter. So be warned, it's not something that you want to be doing all that often. But know what multicast is. Know the upgrade path to NSX 6. Know what you need to do, what versions of VCNS Manager you need to be at, and know what versions of ESX Hosts you need to be at, and know what versions of Proxy vCenter you need to be at. The answer might surprise you on the ESX Host front. You don't necessarily have to be on 5.5 to be able to use NSX. You certainly need to be up towards 5.5 for VCNS and for vCenter. But just know that upgrade path. Certainly know what you need to do. It's all going to be in the installation upgrade guides, so just know it. Know what the difference is between traditional edge network and distributed routers and firewalls. I've covered that somewhat today. Hopefully you got a gist of what the difference is between them. Instead of having that traditional router that you can see in your vShield manager, or that router that you can see in your data center, it's all going to be on the ESX host. It's all contained. It's just like how we came along with VMware all those years ago. We took the data center and we compressed it into a single box. And in that single box, you've got a load of VMs running on it. Same thing with networking. Take that networking cab in your data center, and you're going to be taking devices out of that and compressing that into just regular little VMs. And in distributed routers, you're definitely putting it down onto a hypervisor layer. And that gives you all the performance you need. And one big thing, it may have VMware in the name, but it doesn't just need, it can run on systems other than vSphere. That's something that people tend to forget. You can have on KVMware Zen. I think it's an open switch, I forgot what the terminology is, but there is other open source versions of these distributed switches you can use. You can have it over your Zen estate, and you can have the same type of policy-based firewalling, etc., done from that same NSX manager. NSX itself has been split into kind of NSX vSphere and NSX multi-hypervisor. So be aware of that, read up about it, and don't get sucked into just thinking this is a VMware product for use on VMware technology. I'm not going to cover spine and leaf. It is in the design guide. Everything you know is in that design guide around that. It is know about how you can, the redundancy in it, the capability of if you lose a spine, what happens to your network design. It is verbatim in that document, perfect. I went through it today, and it was very much covered everything that you needed to know. I'm not going to reinvent the wheel and waste everyone's time just reading out what's in the design guide. And do the VMware sample questions. Treat it as an open book. Obviously, you get one of them wrong, so you can sit it again at a later date. But go through those questions. There's also Paul McSharry. He's done an excellent set of sample questions. I think he's up to 4 or 5 groupings of questions. I shot them the night before my exam, and they really got me in the zone, and they gave me the confidence to actually think that I might actually be able to do it. So I would really urge you guys to actually look at those particular sources for an idea of what a VCP-NV looks like. Again, this is all the usual stuff you'll see, and said again, repeated. The blueprint, genuinely, I looked at the blueprint after I did the exam. It is all there. There was no questions that weren't on the blueprint. There's stuff on the blueprint that I wasn't asked, but anything I was asked was on that blueprint. For me, because I didn't have an NSX environment right in front of me, I basically had to know from the NSX admin guide, design guide, and installation guide. Just like any VCP, it's knowing about the technology. It's knowing about how to install the technology. This is not a VCAP. This is not an exercise in, architecting a solution. This is not a VCAP in how to do day-to-day management on it and fixing and troubleshooting. This is basically how to get out of the box, how to set it up in a loose way and install it. So those documents are perfect for that. The NSX 6.1 online documentation was released there, I think it was on Friday. NSX 6.1 was officially made GA, I think it was last Wednesday evening, and they're releasing the software, I believe, now. So it won't be installed in anyone's environment unless they have access to a beta. So don't feel like you've been left behind. No one's really got their hands on 6.1. But what you can do is, if I skip a few points down, you can do the hands-on labs. They are absolutely fantastic. I did use one, and strangely enough, it didn't. The controllers weren't working for me, but it did allow me to actually go through the interface, know where all the options were, get acquainted with the terminology, get acquainted with how to prepare a host, and there was a lot of familiarity with VCNS Manager. It was a case that VCNS Manager was finally made to actually look good, with also all these extra little options added in. Explore it, use it, it's free, and there's several other labs here, but this is just particularly the one I went to, and it gave me that little bit hands-on experience that I needed to actually, go that extra bit and pass the exam. Again, I've included Paul's practice questions. His fantastic resource for the community. Big shout out to him. Thank you very much for that. He was a lifesaver for me. Do them. And the sample questions there as well. Again, do them. Don't ignore them. They're there for a reason. I went and I bought the Networking for VMware Administrative book off Amazon. It won't cover pretty much anything of NSX or anything like that, but it gives you that full deep dive into networking. Now, when I say deep dive, you're not going to, want to tear your hair out or, just run out screaming. It is an excellent book at explaining, all about DV switches, standard switches, all the rest of it. Some of you guys may not be able to get access to an Enterprise Plus license and therefore play with a DV switch. So this is where you can actually read through it, look at the configuration, understand limitations, what new features come in, etc., etc. So I would urge you guys to actually pick up. I'm sure there's plenty of other really good books out there, but it was one of the few books I bought about VMware over the last few years, and I didn't regret it one iota. And that's me basically done as part of the webinar. Thank you for attending. If there's any questions or anything like that, feel free to ask, but be kind, this is my first one.
I noticed Frank Bruchel said the decision algorithm is a reason for odd numbers. Otherwise, controllers could end up in a split brain.
Okay.
I think he's...
Yeah, there we go. So that was the section that we were talking about there. Okay. Thanks, Frank. Much appreciated on the clarification there.
Question. Yeah. Okay. Yeah. Looks good.
Well, I got in the way with not having too many questions, so.
Yeah.
Brilliant stuff.
Pretty well anyway. Yeah, I mean, how can people get in contact with you?
Okay, right. I will stick up, obviously, my details on the bottom of the slide, but my Twitter handle is Wynne, quite simply. And I'll post up my website address with all the details of this shortly. I have to choose which website to stick it on, whether it's my personal one or whether it's a work one. But I will primarily Twitter or LinkedIn as well. I'd be more than happy to accept people on LinkedIn and have a chat with them.
Cool.
So,
good.
Thanks a million for the opportunity to actually present, and I hope I gave a little bit of an idea about how to get through Objective 2. I didn't have to go through any of the install stuff, thankfully, in this objective. That will be for someone else to have to go through, but this should give you at least the basics in NSX.
Yeah. Perfect. And then, guys, next week, it is tentative at the moment, but I'm sure they'll be up for it. Will be Renee van den Bedum, so VCDX 133 will be covering VCP-NV Objective 3. So that is tentative, so hopefully he'll confirm pretty soon. But yeah, we should have Renee on next week covering Objective 3, and then literally the week after, tentatively, we have Paul McSherry, who was linked to his blog. Paul will be hopefully coming on covering Objective 4 the week after. So we are trying to do all of the objective, and unlike we've done some of the other objectives, we are trying to do it in order so that people can watch it and get them in order rather than being jumping around. So hopefully everybody enjoyed it. Yep, loads of people saying really good and thanks. And yeah, I'll get the recording encoded and uploaded as soon as possible. And yeah, thanks again, Ross.
Thank you very much.